Okay guys, in this video, and again I'm going to shoot this video and then there'll be another one that will be over special right triangles because we're going to start moving a lot quicker in geometry, so be ready and make sure you put in the time that's required because there's still a lot more stuff to cover before the semester is over. Alright, here we go. So this is just to recap everything that we've covered up to this point. So we've talked about Pythagorean Theorem, which is a squared plus b squared equals c squared. Remember that the purpose of the Pythagorean theorem is that when you're given two sides of a right triangle, okay, you can find the third missing sign. Find third side. So you're given two sides, and again, it has to be a right triangle. Okay, so if you have two of the legs, you can get hypotenuse. If you have a hypotenuse and a leg, you can get the other leg, okay? The Pythagorean theorem converse, of course, we filled in the top of that sheet. And remember that one is just there's these stipulations that, you know, if you can square both of the legs and add them together and it equals the square of the hypotenuse, then it's a right. If the sum of those two sides is greater than the square of the triangle, then it's acute, and so forth. So just definitely memorize these because I'm not going to give you this on the test. Now the last part that we definitely want to make sure that we understand. Stop. Sorry, dog and bird stuff. Stop. Okay, is for this converse stuff. Make sure that you read and understand this part, and I'll read it again. It says, first determine if the three sides or the three side lengths can form a triangle at all. So again, you have to make sure that you understand that the sum of the two small sides, you know, the sum of the two small sides must be greater than the third side. So if you look at this one, if I do 20 plus 21, y'all know that's 41. 41 is greater than 29, so therefore I can classify this triangle. So of course, what would I do? I would square 20 for 400, square this, and I think that's 441. And then square the 29, and then again, if that value is bigger than the square of this one, then I would begin to classify. Okay, so I will do a couple of these, all right? But just to be clear, before you even start to classify, you have to make sure that the sides follow this, okay? The sum of the two small sides must be greater than the third side. So let's look at number 4. So if we do 17 plus 17, that's 34. And 34 is greater than 22, okay? So then therefore, when I begin to do the Pythagorean theorem, and I know that 17 squared is 289, so again, I'm going to square this one. Remember, the long side is the hypotenuse. So if I do 289 plus 289, and then I'm also going to do 22 squared, which is 484. So if I do 289 and I add that together, that's 578, which clearly that is greater than 484. So if the sum of your a squared and b squared is larger than this side squared, it's acute. So number 4, like we said, is acute. Okay, I'll do one more. Look at number 8, and this is in the practice. If I do 11 plus 19, so I got 11 plus 19, which is 30. That is greater than 28. So that means I can classify this. And then if I begin to square all three of those sides, so 11 squared is 121. 19 squared is 361. And then 28 squared is 784. So I'm going to go ahead and drop down the 784. And now when I add together 121 plus 361, sorry for the bird, he's fussing. So because this side, the c squared side, is greater than the sum of the a squared and b squared, then we're going to say it's obtuse. When those two sides are smaller than this one, obtuse. So this one was obtuse. Okay, last one. So 8 obtuse, 4 is acute, and again, this one right here, number 3, the answer is not a triangle at all, because for this one, if you do 4 plus 11, which was 15, 15 is not greater than 16. so therefore not a triangle. So 3, not a triangle. This one was acute. I didn't complete this one, but you guys can do that. Again, square 20 squared for 400, square the 21 squared, square the 29, and figure out which side is bigger. This one was obtuse, okay? So that's how you work with Pythagorean Theorem converses and classifying the right triangle, okay? That takes care of that. All right, so now let's move to geometric mean. So again, we've already talked about how to do the converse, which is classifying the right triangle. Okay, we talked about that. We know when to use Pythagorean theorem. All right, so now let's look at geometric mean. And we're also going to look at the word problems. Okay, so these we've already worked out, but I'm just going to zip back through these. So remember that we had a relationship between the altitude and with the altitude, which is the inside, and these two segments on the right triangle. So we have x is equal to AB, square root of AB. So if you look at number 8, all we did here is say x is equal to, and we're doing the square root of 12 times 8. So when we multiplied 12 times 8 under the square root, or radical, we got the square root of 96. We did prime factorization, and we got 4 roots of 6. Okay, let's look at number 9. I actually shot this one earlier, and I'm reshooting this video, so we work this one out for you guys. There's the altitude. Okay, so they want to know what x is, the altitude. This right here was another right triangle, and we had 5, and this whole value here, corner to quarter, was 37, and they want x. So what you do here is, let's use the same formula. X is equal to the square root, and then we have, you know, a times b, but we don't know this value. But however, clearly, because this total is 37 and this piece is 5, that means this one is 32, because again, 37 minus 5 would give this. So this is 32 in length. Everybody see that? All right, so now I'm going to do 32 times 5. X is equal to the square root. And I'm going to do 32 times 5, which is 160. And then I'm going to begin to do my prime factorization. 16 times 2, 5 times 2, those are primes. This I'm going to break down to either 8 times 2. I could also do 4 times 4. 2, 2, break that down to 2, and 2. Okay, and then keep up with your pairs. So because I have these two as a pair, I'm going to bring out a 2. Here's another pair. And then these two are the singles. So that's going to be just the root of 10, 5 times 2. So the answer to this is 4 square roots of 10. 1 second. Okay, so I hope everyone can see that from this one. Again, this was number 9 in the practice. Okay. All right, let's do number 11. This one, they gave you an altitude of 21. The right angle was right here. They told you this piece was 30. And then you had this piece here that they wanted for x. So again, the setup is still x equals the root of a times b. And I'm going to go ahead and call this piece b. Alright, now notice that they gave us the altitude, so I'm going to plug in for that x. This is 21, even though, yes, I'm looking for this x, guys, okay? But just to stay true to the geometric mean formula, that's what I'm going to do. Alright, so I got 21 is the altitude, equals the root, and again, I'm calling this piece a, so that's 30 times b. And then, of course, if I want to get rid of that square root so that I can get b to be by himself, then I'm going to square this side, and I also have to square the other side. Because, again, what separates those two sides is the equal sign. So, going from left to right, 21 squared is 441, equals, and then remember, the square root and the square cancel out, so that just drops out that 30 times b. And now I'm going to divide by 30 because multiplication is happening here. Opposite is division. What I do to one side, I'm doing to the other. So now if I do 441 divided by 30, b is equal to 14.7. So that's how much this piece is. So if they want to know what x is, we're just going to do 30 plus the 14.7, which is 44.7. That's the x that you're looking for. That was number 11. Okay, so remember that they have the geometric mean with the altitude theorem. All four of these pretty much have been discussed. So now let's look at the geometric mean with the leg theorem. So I'm going to work on number 13 and also do number 14. Okay, so for number 13, this is what they gave us. I'm going to move up here. For 13, they gave us a right triangle. This piece here is 7. This entire length here is 12. And they're looking for this x here. That's cool. Again, that is not the altitude they're looking for. Alright, so if we work a little bit backwards here, here's what we get. If this piece here is 7, right, we know that 12 minus 7 is 5. So that means this piece here is 5. I just did some subtraction. Okay, cool. And then what I would do is, you notice that, hey, I have the A, I have the B, but I don't know the altitude. So you could get this side because there is a small right triangle down here at the bottom. Okay, so I want to basically get this one, and for the sake of the fact that this is an x, let's call this a z. So we're going to spit out z, and then when I have those two sides, guys, then I can use the Pythagorean theorem and get that third unknown side. So the way I'm going to set this one up is z, which is the altitude, equals the root of a times b. So that's 7 times 5. And now I have z is equal to the root of 35. 35 is a prime number because of 5 times 7. So I'm just going to leave that like in square root form. So that's what this altitude is, the root of 35. Okay. Now, very carefully, remember this is a leg and this is a leg. So I'm going to basically do a squared plus b squared equals c squared. So I'm going to do a squared, which is z squared. Okay, so I'm just going to write the formula down. Again, I'm calling this side a. So since z equals the root of 35, but I have to square it, and then I have to do 5 squared, that's my b, which that's 25. And then I will be spitting out c squared, which again, that's the x. So if you want me to, I'll go ahead and change that c to an x. That's the hypotenuse. Alright, so now when I do this math, remember square roots and squares cancel out. So this value here is just going to be 35 plus 25 equals x squared. And 35 plus 25 was 60 equals x squared. And I'm trying to solve for x. So I'm going to take the square root of both sides to get that square off of the x. So x is equal to the root of 60. Okay, and then I'm going to just show the prime factorization again. So if I have 60, and I'm trying to simplify that down, that's 12 and times 5. There's a prime number. 4 times 3, there's a prime number. Break this down to 2 times 2. So this is a pair here. So I'm going to say 2 root, and here are the singles. So this is the same as 2 root of 15. That's that x value there. Alright, I'm going to do one more. I know it's a little messy. One more. Again, this is all about geometric mean. Okay, so for this one, let's do number 14. Because on number 14, they wanted an x, y, and a z. Also, again, if you're, having still a hard time with this, please come to tutoring. I have it Mondays and Tuesdays after school. All right, so when I draw this triangle for number 14, and there's the altitude. Okay, they told me this piece here was 24. They wanted to know what x was, the total length. And then they called this altitude y, this hypotenuse z, and then they also told me this was 27. All right, here we go. So for this one, what I notice is, well, if this piece here is 90, then guess what? That means this is 90. Because these are linear pairs. So therefore, I can use the Pythagorean theorem to find y. Okay, so I'm going to go ahead, again, this is C, let's call this A, I'm looking for B. So I have 27 squared is equal to 24 squared, plus, and again, I'm going to leave that as y squared. That's like my B leg. All right, so now when I do 27 times 27, I get 729 equals, and then I'm going to do my calculator, 24 times 24, which is 576, plus y squared. Now I'm going to move away the 576 because I'm trying to get y by itself, but it's still y squared. And when I subtract 729 minus 576, I get 153, which I already know that's a prime number, okay? But again, to get rid of that square, I have to square root this side and that side. Y equals the root of 153, and I'm going to leave that like it is because it's a prime number, okay? Never in my multiplication facts have I seen 153. All right, so that takes care of the altitude. All right, now that I know the altitude, if I want to, I can spit out this piece because I know the geometric mean formula says x is equal to the square root of what? A times b. So let's call this little value b. Okay, and then once I spit out b, then I'll sum together these two and get x. So I'm gonna, again, y is the root of 153. I'm gonna go ahead and box that, so that'll be one answer for the teacher. So again, I'm gonna set this up as y equal the square root, and this is a times b, so 24 times b. You see that? Okay, and then what is y? Well, y is the square root of 153 equals the root of 24 times b. Okay, all right. So now to sit back and spit out what b is, I'm going to square the left side. I also have to do it to the other side. The square root and square will cancel out, and that 153 is just going to fall out on the left. The square root and square cancel out. That 24b is going to fall out. And then 153 divided by 24, b equals, and I'm just going to carry this out as 6.375. Everybody good on that? So now that I know b is 6.375, I'm going to add that to 24. So x is equal to 24 plus 6.375, which is 30.375. That's x. So I got y and I got x. Last part now is to spit out z. And then again, because this is a right triangle and I have those two legs, the b value and y, I can get z. Okay, so I'm going to do Pythagorean Theorem because I have two of the sides. I want the third unknown side. So I'm going to say z squared is equal to b squared plus y squared. I don't know what z squared is, but clearly I know what b is, which is the 6.375 squared. And y squared, what was y? The root of 153. So I'm doing my substitution with parentheses, but I have to still square that. Okay? All right, so now I'm going to drop down the z squared again. And then I'm going to multiply the 6.375 squared, which is, 40.64. And then again, the square root and square are going to cancel out. This is 153. So I'm going to add those two values together. 153 plus 40.64. Okay, so z squared is equal to 193.64, and then I'm going to take the square root of the left, the square root of the right, the square root, and the square cancel out. Z equals, I'm taking the square root, I get 13.92. Done. Alright, so now I know what x, y, and z is. And I do recommend, again, try any of the ones in the practice that are not completed. And then don't forget that you had a homework on this that was similarity and geometric mean. So I don't have that paper though. Okay, so just to recap, the quiz is definitely going to be over Pythagorean Theorem, Pythagorean Theorem Converse, where you classify, geometric mean, and now let's talk about Pythagorean Theorem word problems. So this is in the practice, And unfortunately, I'm reshooting this video to make it a tad bit shorter. So disregard how I did the bottom. I'm just going to read the word problem here. Okay. And we talked about these up here, but I'll work number 5 and 6 really quick too, just to say that I touched on Pythagorean Theorem. Okay, so I'm going to kind of side shift and then go to word problems. Alright, so this one, as you can see, it tells you that these two pieces are congruent. This is an isosceles triangle. They told you that the altitude inside of here is 20, and they gave you the base is 18. What they want to know is, what's the side lengths, right? Okay. So, well, between you and me, because this is an angle bisector, it forms a 90-degree angle, so this piece is perpendicular. It cuts this side length in half. So this is 9, guys, and this is 9. So now when I draw just a piece of the right triangle, remember this is Pythagorean Theorem. So this is 9, this is 20, and I'm looking for the x, which is the hypotenuse. So I'm just going to say 20 squared plus 9 squared equals x squared. 20 squared is 400. 9 squared is 81. And then I have x squared. So basically I'm saying that x is equal, again, you got to take the square root of this side and that side. So to find x, it's the square root of 481, which I'm going to just type that in the calculator. 21.93. Okay, this is the value of both of those sides. Okay, all right, let's look at number 6. Again, these are straightforward. So you have 5.3 squared plus 12.8 squared, set it equal to x squared, but don't forget that you have to take the square root to get the value. This one, you do subtraction. So, I don't know, I'm going to just do them. All right, for this one, if they say this piece here is 17 and it looks just like a little kind of square or rectangle in the middle, then I believe this piece is 17. Okay. Then I also am going to say, then I can find this piece here because this also forms a right triangle. So if I recreate just the right triangle on this trapezoid, I have 17. I don't know what this leg A is, and then the hypotenuse is 19. So for this one, I'm going to do 19 squared, which is c squared, equals 17 squared. Let's call that b squared, and then again, I don't know what a is. So again, that's your c squared, b squared, plus a squared. So 19 squared is 361. 17 squared is 289. And then I'm just going to subtract that 289 over to this side because, again, I'm trying to get a by itself. So 361 minus 289 is 72. So I have 72 equals a squared. I'm going to take the square root of both sides. And that's where I get a is equal to 8.49. Okay, so I hope these make sense to you and they're straightforward. All right, let's get to word problems. All right, so in here I'm just going to talk you through it because I already drew this one. So it says Scott is using a 12-foot ramp to help load furniture into the back of a moving truck. If you've moved before, you've done this. If the back of the truck is 3.5 feet from the ground, what is the horizontal distance from where the ramp reaches the ground to the truck? Again, what is the horizontal, this way, distance from where the ramp reaches to the ground and then to the truck? So I recreated this. This is the truck. Again, I know that this should be down on the ground. Okay, people, I'm not an artist. But here's this ramp coming off the back of the truck. They told me that the truck is 3.5 feet from the ground. So I just drew this vertical distance from the back of the truck to the ground because it does make a spacing there, even though the wheels are on the ground. So I recreated and blew up this triangle. And so there's the 12-foot ramp. Here's that little, again, top corner of the back of the truck down to the ground, creates 3.5, and I'm looking for the horizontal distance from, again, the ramp to the back of the truck. Okay, So if you set up Pythagorean Theorem, this is your c squared side. So I put 12 squared equals, I'm calling this side b, that's the 3.5, and then the x squared is the horizontal distance from the ramp to the back of the truck. And then I do my math. 144, this was 12.25. I subtracted 12.25 over from the 144, and I got 131.76 equals x squared. And then I took the square root of this side, square root of that side. So the square root of 131.75 is 11.48 feet. So that horizontal distance right here, 11.48 feet long. There you go. All right, let's move to another word problem. The next word problem I have, and again, these are from the homework. When we get to class, we will work on the warm-up, the word problems for in the practice. All right, again, I already worked these out. All right, this one says, you have a 35-foot wire, and it is secured from the top of the flagpole. Sorry about that. There's a 35-foot wire secured from the top of a flagpole to a stake in the ground. So I drew a flagpole, and then here's that wire that's 35 feet to the stake in the ground. I could have drawn it a lot more closer to the ground. So now it says if the stake is 14 feet from the base of the flagpole, well then how tall is the flagpole? So again, there's the flagpole, there's the 35-foot wire, and they said that the stake to the base of the flagpole is 14 feet. So I just redrew this triangle. And again, I could have brought this a lot closer down to the ground and got something a lot more realistic so I would get the whole height. But we're good. I mean, it's straightforward. So we got 35, 14, and I have the hypotenuse and the leg. So in my brain, I think about subtraction. Okay? So when I start doing my math, again, I called this side A, B, there's C. So I did 35 squared, which is the hypotenuse. 14 squared was my A, and I'm trying to spit out that other B value, which is the height of the flagpole. So when I did 35 squared, I got 1,225. I did 14 squared for 196. Remember, I subtracted this value away from the 1225, and that's where I got 1,096. And then I took the square root of that, square root of this side to get rid of the square on the x, did it to this side. And so basically x is equal to, x equals the square root of this, 1,096, which came out to 32.08. 32.08 feet is the height of that flagpole, which is pretty realistic. Okay, last one, number 10. Here it says, if the diagonal of a square, so I drew a square, it says the diagonal is 11.3 meters. So I drew that diagonal, it's not perfect, and we know these are all 90-degree angles in the corners. Now what's hard about this one, and they wanted the perimeter of the square, is that you have two unknown sides, and you only have one. So this will lead me into the next video, which I'll spend a lot of time very carefully talking about special right triangles. So this one, again, they gave you the diagonal, which is your hypotenuse, that's your C, but you don't know A or B. However, you do know A and B are what? Equal to each other. So you have to use special right triangles to solve this one. And this one is a 45, 45, 90. And because it's a 45, 45, 90, this is what we know. We know that the two legs are always equal to each other on a 45, 45, 90. And the hypotenuse has a length that's called x root of 2. So whatever this x value is, and then you multiply it by the square root of 2, that will give you the hypotenuse. That's what makes it special. There's a relationship and some formulas between the three sides. All right, so again, a 45, 45, 90 goes x, x, x root of 2. So because the hypotenuse is, there's a formula for it, which is x root of 2, I set the 11.3 equal to x root of 2. All right, so once I put x root of 2 is equal to 11.3. Remember, x root of 2, it's just a number. Even though it's in the back, it's just a number. So I just did division. I divided away the square root of 2 to both sides. And 11.3 divided by the square root of 2. So I got x is 7.99, which is about 8 meters. Okay? So this side is 8, 8, this side is 8, this one is 8, and that one is 8. And so once I did 8 times 4 for the perimeter, the answer is 32 meters. All right, guys, I'm going to cut the video here. Hopefully this was helpful. And again, just rework everything just to make sure you're straight on the concepts to be ready for the quiz.